Hi everyone, and welcome back to another video. Today we're going to talk about scientific facts with large numbers. They appear frequently in fields such as mathematics, cosmology, statistical mechanics, and cryptography. Let's get right into it. How many seconds old are you? Well, you can actually work this out by using a calculator. There are 60 seconds in a minute, and if you times 60 by 60, you get 3,600 seconds in an hour. When you times 3,600 by 24, you get 86,400 seconds, which is how long a day is. If you times 86,400 by 365, which is how many days there are in a year, you get 31,536,000 seconds. Interestingly, around half the people in the world have never known the joy of celebrating their billionth second of life. You turn a billion seconds old when you're about 31 years old and 3/4. But because of leap years, it makes it harder to be precise with figures. Twitter, or X, is an extraordinary form of social media and a lot of the time controversial. Every second, about 6,000 tweets are tweeted, which corresponds to over 350,000 tweets sent per minute. 500 million tweets per day, and around 200 billion tweets per year. Assuming these stats were similar in the last 10 years, it's estimated the total number of all tweets would be at least 4 trillion. Humans see themselves as the dominant species of the planet because of our intelligence, but it's a very different story when it comes to quantity. For every human alive on Earth, there are about 1.4 billion insects, which means there are approximately 11.2 quintillion insects on our planet. But what about sand? Are there more than 11.2 quintillion grains of sand on Earth? As it turns out, yes, much more. The number of grains of sand on Earth is approximately 7 sextillion, which is much more than the number of insects on the planet. Sextillion is the next illion sequence after quintillion. Have you ever wondered how old our universe is in seconds? If the Big Bang Theory is true, then the Big Bang is estimated to have occurred around 13.8 billion years ago, making our universe 13.8 billion years old. After doing some complicated math, experts were able to calculate the answer of 436 quadrillion, or this number of seconds since the Big Bang to be more precise. They obviously can't measure the exact second, but this is still an interesting thing to know. However, that figure is still much smaller compared to the number of insects on our Earth, and is certainly not bigger than the number of grains of sand on Earth, as I previously discussed. This is surprising since we are talking about the number of seconds since the Big Bang, but as you can see, the numbers will only get bigger from here. The number of galaxies in the observable universe is said to be around 2 trillion, and from our previous topic of Twitter, it's hard to comprehend that there's more Twitter posts that have ever been posted in history than there are galaxies in the observable universe. But how many stars are there? Our observable universe has approximately 1 septillion stars, which is 1 followed by 24 zeros. Just to put that into perspective how much this number is, it would take around 31 quadrillion years, or approximately this figure, until the number of seconds since the Big Bang matches the number of stars in the universe. There are more atoms in one human being than there are stars in the observable universe. The number of stars in the observable universe is estimated to be 1 septillion as mentioned before, but the number of atoms in one human body is around 7 octillion. If we multiply 100 trillion cells by 8 billion people, we get about 800 sextillion total cells in all humans on Earth. That figure is still much smaller compared to the number of atoms in just one human, and even all stars in the universe. Bacteria is everywhere, inside of you, on your phone, in your room. In fact, virtually everything you come across in everyday life has bacteria living on it. The number of bacteria on Earth is approximately 5 nonillion, which is a 5 followed by 30 zeros. Bacteria are the oldest organisms that we have ever known, and the sheer amount of them is just astounding, especially when you realize how unaware you are of these microscopic creatures on a daily basis, and how highly ubiquitous they are. You might not be able to see them, but they really are everywhere around you as we speak. When a deck of 52 cards gets shuffled in a random sequence, it is one of 80 unvigintillion possible shuffle combinations. That is an 8 followed by 67 zeros. This number is so unbelievably large that the configuration you get after shuffling a card deck will never be seen again by anyone in history, and has never been seen in human history. If we were to try and go through every possible combination, 1 decillion people would have to shuffle a deck of cards every millisecond for 2.5 septillion years, or this figure to be exact. We have about 1 times 10 to the 82 atoms in our universe. Since atoms build up everything, from rocks in space to stars to the planets and everything on those planets. But what is truly incredible is that this is nothing compared to when it comes to chess. If you allow illegal moves and let the pieces move wherever they want, then the number turns into 1 times 10 to the 123 power. To reach this number, you would have to take all the number of atoms in the universe and multiply them by 10 tredecillion, which is a number that is already monstrously bigger than the number of stars in the universe second since the Big Bang and atoms in one human combined. But what about the smallest thing to the biggest thing in the universe? A Planck particle, Planck length or Planck volume is the smallest thing or unit of measurement possible in theory. Just like atoms, Planck volumes make up everything, but calling them gargantuanly smaller than an atom would be an enormous understatement. For comparison, an atom ranges from 30 to 300 picometers, whereas a Planck size is around 1.6 times 10 to the negative 35 meters. There are around 1 times 10 to the 105 Planck volumes in our observable universe, and 1 times 10 to the 185th power Planck volumes could fit in the universe from top to bottom. But what about the entire universe as opposed to the observable universe? If we assume the whole universe is 150 sextillion times larger than the observable universe, which translates to approximately 10 decillion light years across, then we could fit 1 times 10 to the 246 Planck particles in our entire universe, which is the theoretical limit for any physical quantity in our universe, according to Alan Guth's cosmic inflation theory. I hope you enjoyed today's video. The majority of the content in today's video was actually my own imagery and footage. I found some of my relevant archives that help support the visuals. I have also timestamped where my content is in the video in the comments section below. There's still a lot we don't know, but until then, stay tuned for more future content.